Okay, gang, I'm going to pick up with 11.1. This part is on inverses. Now, an inverse is an opposite, right? So think about if I wrap a present, the inverse would be to unwrap it. Okay, an inverse is like an opposite. If I add 5, the inverse would be to subtract 5. All right, if I divide by 7, the inverse would be to multiply by 7. Now you're going to do this again in pre-calc, but we are going to touch on some basic concepts. So first of all, I'm just going to go through the labeling of equations. So the most basic equation you can have is called a relation. And I didn't write that one up here, but that's the most basic one, a relation. And there's no rules to how a relation is organized. It's just there is some domain paired with some range, but there's no rules to how the pairing is created. So that would be like the first floor. The second floor would be a function. So now there's a rule. Each x goes to exactly 1y. Okay, that's how you're pairing. That's how you're doing like a pairing. There's a rule to the pairing. That means that the graph has to pass the vertical line test. If a graph passes the vertical line test, it's a function. Now, so if the first floor is a relation, the second floor is a function, the third floor is what we call one-to-one. And so that has to have the previous rule, which was each x goes to exactly 1y. And it has an additional rule, which is each y goes to exactly 1x. So graphically, what that means is not only does it have to pass the vertical line test, it's also going to have to pass the horizontal line test. And why I'm going over this detail with you is because one-to-one is the only type of function that has an inverse or an opposite. Now, it's not that you can't chop up a function to a smaller segment that is one-to-one. So you can sort of chop up a function to find a one-to-one segment in it. But overall, one-to-one functions, the whole function is has an inverse. There's no need to like chop it up. All right, so if we look at a parabola passes the vertical line test, but it doesn't pass the horizontal line test. All right, so since it passes the vertical line test, it's a function, but it doesn't go all the way to the third category of being one-to-one because it fails the horizontal line test. It touches more than once if I draw a horizontal line, which means that each y doesn't go to exactly 1x. Meaning like we've got two different x values here with the same height. All right, so the highest this one goes is a function. That's the highest that one goes. Now, if we look at this one passes both the vertical and the horizontal. So this is what we would call one-to-one, and that means that this function has an inverse. This function does not have an inverse, but because it's not one-to-one, but we could, for instance, take just half of it, and if we take just half of it, the half of it is actually one-to-one. So we can modify a function to be one-to-one if we cut it up. All right, so this means that this one has an inverse. This one has an opposite, the second one I did. Now, the big part I want you to be able to do here is algebraically find an inverse, and that's not hard to do. You'll find this quite easy. All right, and I'll just do a couple examples with you. So this function is linear. All linear lines pass the horizontal and vertical. So that means that all linear cases have a inverse, have an opposite. So this is how you do it. I first want you to replace f of x with y. Then I want you, let me just write that out in case you need to see it. Replace f of x with y. All right, then I want you to swap x and y, and that's actually what makes it an inverse. When you swap the domain and range, that's actually what an inverse is. They're opposites. So this is the point where it becomes the inverse right here when you did the swapping, but then I want you to solve for y. So if I solve for y, I'm going to move the 4 to the other side. Let me just sharpen this pencil 1 second. All right, then I'm going to divide off the 3. You could write the 3 in the bottom, or if you prefer, you could write the 3 out front as 1/3. They're both the same, okay? And the very last thing I want to ask you to do is to label it as the inverse. So to label it as the inverse, this is going to look a little weird, okay? But the inverse notation is f to the little 1. F to the little 1. I know that may look like reciprocal, but it's not. In function notation, reciprocal has to have little parentheses around the -1. So this function is the inverse. This is the inverse of the original. These are opposites. And in pre-calc, you'll be asked to take the composite of these, because if you take the composite of the original and its inverse, it'll actually output an x. They undo each other. All right, so this is the answer. So let's go through those steps again, because that's what I want you to be able to do, okay? All right, so we're going to do those steps again. Now, this is a cube function. The cube function actually looks like a cube root function. A cube root function sort of looks like an S on its side. So it is going to have an inverse. This one is quadratic. This is an x squared, and x squareds don't have an inverse unless you chop them up. All right, so let's see if you remember those steps I just did. So the first thing I asked you to do is replace f of x with y. The next thing I asked you to do was to swap x and y. Okay, the next thing I asked you to do was solve for y. Now to solve for y here, we've got to get this cube root off. So for me to do that, I have to actually cube both sides. And the cube root and the cube will cancel each other. All right, I'm almost there. I just got to subtract the 2 to the other side. And then the very last step I asked you guys to do was to label it as the inverse. So f inverse of x equals to x cubed minus 2. Now the very basic functions, you can actually tell they're inverses because they're going to look opposite, right? The opposite of a cube root is a cube. The opposite of adding 2 is subtracting 2. Now this is going to be a slight bit tricky what I'm about to say, but if you like mathematics and you think you're going to do something with it, it's an interesting concept. The inverse is the opposite operations in the opposite order. It's the opposite operation in the opposite order. So for instance, if I plugged in an x value here, I would first add 2 and then cube root. If I plugged in an x value, I'd first add 2 and then cube root. If I plugged in an x value here, I would cube it first and then subtract 2. So I would do the opposite operations in the opposite order. Don't worry about that. It's just like a little tidbit if that interests you. All right, last one on our platter is this one. And then that's it. I'm finishing the video. This is the most difficult one to do because it's very algebraic intensive. All right, here we go. We're going to do the steps one more time. All right, you're going to replace f with y. You're going to swap x and y. All right, now this one's a little bit more difficult to do. Now you're going to solve for y. So there's 2 ways to do this. Some people like to get an LCD and then cross the bottoms out. Other people like to cross multiply. It just depends which way you want to do it. I'm cross multiplying here. Now because I want to get at the y, I can't have it sort of stuck in these parentheses. So I have to distribute this so I can sort of free willy, get it out of these parentheses. All right, now if you notice, let me just put this x a little closer. It's too far away. Now if you notice, I have 2 different y values. I have one here and one here. You need to get them both to the same side. So I'm going to move this guy over to the left. So I subtracted this y to move it over to the left. Now I just want the y terms on the left, so I don't want this 3x. So I'm going to move the 3x to the right. Doesn't matter what order you put things in. So I'm adding the 3x to move it to the right side. So basically what I did was I moved, I don't know if you could see both, I basically moved the furniture. That's what I did. I moved the y to the left, the 3x to the right. Now this is usually where students get hung up, and it's so obvious it's not obvious. So don't beat yourself up if you don't catch it every now and then, okay? The y now is a common factor. So that means you can factor it out. So I factor out the y. Now I'm going to divide off the x minus 1. And last step again is to write it as label it as the inverse. And then that's the final answer. That's the inverse of the original. Okay, gang, so this is what I'm looking for. I'm looking for you to be able to do the inverse. And I'm looking for you to be able to know if a function has an inverse or not. So remember, if a function has an inverse, it has to pass both the vertical and the horizontal. It cannot just pass one. It has to pass both. When it passes both, that means it's 1 to 1, which means it has an inverse. All right, gang, that's it on this video. I'll catch you.